Let's start our today's session. Okay, so in our previous day we talked about we started talking about GIS, basically QGIS. As I have mentioned, you will be doing your practicals with uh, QGIS. Okay, I hope you can see my screen. So I think we stopped at this point. We talked about our everyday usages of GIS, how GIS can be used every day in our lives, and what are the applications that have been developed in order to use GIS and GIS related concepts. So applications like Google Maps um, and other geographic related applications have been developed in order to use geographic information systems for the betterment of the human being. So we stopped at this point, and I also have shared the lectures with you all. I don't know if there is some issue with the what you say, the sharing options. If please check with the documents that I have shared, because some people have asked permission from me. As I remember, I have given permission for all the documents for all the people who get the documents, but please check it, and if you have some issues with permissions, please let me know. So maybe I'll like share again with you all or something. Just let me know. Okay, so yeah, so basically GIS, we use GIS for decision making, to make decisions or to plan the future. We need to plan our future. We need to build cities. We need to know the weather, what will come in the future. We need to be ready for it. So for those kind of things, and for many other reasons also, we use GIS. So before moving on to QGIS, I have something else to share with you all. Okay, so here so we will be talking about GIS concepts. So before moving on to QGIS and starting our practical sessions, we will talk about we will talk a bit about the concepts that you need to know before start working with QGIS. So first of all, we'll see why GIS is unique. So GIS handles spatial information. So what is spatial information? This information is referenced by its location in space. In space means on the earth, right? On the earth or above the earth or below the earth. So whatever layer the information refers to, it this information is spread on a surface, right? The information that we are using for doing our analysis in our GIS, basically in QGIS, this information is spread throughout a surface. So this surface can be on Earth, it can be among our country or among our world, right? It can be information based on the Earth, or it can be information based on some surface below the Earth, maybe underwater, right? Temperature, how temperature of how ocean temperature is differed in a surface below the ocean or below the water. Okay, and it can also be some information related to the air or the sky, right? So some information, it might be related to a surface among ourselves, like let's say the pressure or the humidity value on a surface, on a horizontal surface in our surrounding, right, in our air, like that. So however, the information is referred by its location, maybe the GPS location, maybe some other coordinate location. It is referred by the location on a space, right? So all the information in GIS handles spatial information. It makes connections between activities based on spatial proximity. So as I said previously, all these information which is gathered through activities, these activities are based on spatial proximity. All these activities are happening in a spatial manner, on a space, right? So this is one kind of okay, yeah. So this map is based on it is a map created in 1854 based on the disease called cholera, which was a major disease like this COVID-19, which we are facing nowadays. In 1854, in those days, this disease called cholera was spreading throughout the world, basically in Europe. So in London, how this cholera epidemic has been spread has been it has been mapped, right? So how the cholera deaths has happened, the cholera death is being mapped using this cross. This small red color dots are mentioned as cholera deaths, and these are water pumps. So these circles or these points are referred to water pumps. So basically the doctors and other researchers, they couldn't find the reason for the spread of cholera, right? And they tried different medications, they tried to find reasons and like that. And at some point what they did was they mapped all the deaths which were happened due to cholera, and then they found that the deaths basically happened through water. Why? Because the deaths were spread among water pumps. So where there were water pumps, or within the area of the water pumps, there were more deaths happened. So the doctors and those people, They identified that water was one reason, maybe for spreading, maybe for increasing, maybe for creating this disease, and they treated accordingly, right? So like that, we can find answers to questions using maps, right? So here you can see all the information about water pumps, information about cholera deaths were mapped, or they were drawn or located on a space, on a spatial concept, right? So GIS has been developed from digital cartography and CAD system. So cartography means drawing on a spatial surface using coordinates, right? Using coordinates means Cartesian values, using X and Y Cartesian values. I think you have learned about Cartesian uh, drawings in your school, right? So cartography is drawing among this Cartesian space, and CAD means computer aided design. So here computers are being used to design these maps, and database management systems are also used for they are used for storing certain information based on these Cartesian values. So in database management systems, we use X and Y Cartesian values to store data, or we use attribute data. So this is attribute data. So you will be practically working with these things in our practical sessions. Right. So GIS process basically happens by capturing data. We then we register the map base. We develop the map based on the data, interpret data, convert data to digital format. So in order to store and conserve data, we have to convert it into digital format, and afterwards we can store the data. We can process data using certain strategies, and we can display results. So this is basically what happens in a GIS process. So this is the GIS system. So you can see we collect spatial data as well as attribute data. So spatial data is some data based on a spatial area. So maybe using latitude and longitude values, when we talk about certain areas or certain locations on the map, we refer to the latitude and longitude values, akshansha saha deshansha, right? We use them. So so that is spatial data, and attribute data means some data about that spatial data, right? Data about the spatial data. So you will be learning about attribute data, don't worry, right? So this is just to have an idea. So that is the core of the GIS system, and we use many other systems in order as a support for the GIS system. We use statistics and statistical analysis system where we create statistical reports. We use database management system where we store data. We store in a tabular format. We use cartography in order to create maps. We use geographic analysis. We use map digitizing systems where we take maps, take information from maps, and we also use image processing systems where we use images like satellite images and stuff in order to process data, right? So we in GIS we sometimes we take external data, and sometimes we create or we export data externally for external sources. So I think I have mentioned this concept in the last week. We use layers, right? We data layer stacking. We stack layers one on top of the other in order to create a finalized map, right? So you can see here are several layers. So pH layer, nitrogen availability layer, or some other layer. So this, when all of these layers are combined with each other, we can build a perfect map, right? Based on a certain field. So if we take the agriculture field, so several layers related to the agriculture field will be created on top of each other, and afterwards we can create a clearly understandable map. GIS can be used in many areas. So these are some areas where GIS can be used: geoscience, civil engineering, transportation, surveys, mines, tourism, communication. So image processing also can use GIS for their processing and analysis stuff. So these are some softwares where GIS can be used, GIS is used. So here you can see ArcGIS, GRASS, AutoCAD also can use GIS. So like this, there are several software which where you can use GIS. Some of them are freely available, some of them are like you have to buy them. In digital image processing also, these are some digital image processing software. So here you sometimes you can do image processing or analysis of geographical images. So these are some major services in GIS: GIS application software development, remote sensing application projects, thematic mapping, digital image processing services, engineering applications, software solutions, data conversions, complete GIS implementation, consultation. So in GIS, what you related to GIS, what you can do. Right, so you can search about these terms and see whether you are interested in certain areas or certain services, and you can follow them, like you can search more about them. So basically the components of GIS is, the GIS is not only a software or a tool or anything. GIS is a very large area. So in this area, in certain components are included. So one is the computer system. Computer system means if you want to work in the GIS field, you should have this kind of computer system, the hardware side here. So basically you need a CPU and these other hardware items are essential to working with GIS, right? So software, when we talk about software, it includes software like ArcGIS, MapInfo, Geometrica, Autodesk Map. So here you can, by using these software, you can perform GIS operations, right? QGIS is also one software. So here is like a structure where GIS can be, I mean, the usage of GIS in industrial manner. So data management use a GIS database. So there can be other inputs, analysis can be done, outputs will be there. So internal users will use this information. There will be an internal database, and internal management can be happen. and as well as external users, external database, and external management. So this is basically how GIS, the field of GIS will be operated in an industrial manner. So yeah, so this is related to the software part of GIS, and there should be data. So you need a hardware, you need software to analyze geographical data, and you need data. So geographical data you can have in a form of hard copy or digital maps, aerial photos, satellite images, statistical tables, or other documents, right? So and afterwards you have to analyze this data. You need a procedure, and you need an analysis. You need to analyze the data. So procedures are performed using hardware and software. So you need both hardware and software in order to carry out a procedure for analyzing. And you need expert and skilled personnel to handle this data, handle and analyze this GIS related data. So expert knowledge and different users will be there to use GIS at different levels. Right. So basically the main functions of GIS or Geographic Information System will be data capturing, data storing, data manipulating, and data displaying. So capturing data, you can you can digitize, you can scan, you can import from other sources, or you can enter data manually. Right. So when you are storing data, you can use databases, you can use data integration concepts, you can use data warehouses, any way that you can store data, store and manage data. Then you need to manipulate or edit data. So we talked about noise and other stuff where data quality is degraded on the last week. So we need to clean, edit data, dissolving boundaries, layering, georeferencing. So these are all of these are ways to clean and edit these GIS data. And finally, we can display data. So manipulating means you can analyze this data and create results. And finally, you can display spatial and attribute data. Right? You can display the spatial and attribute data, which will be the result from the previous step where data manipulation and editing happens. Right? So when we talk about data manipulation and analysis, spatial analysis will be there. Spatial analysis means analyzing analyzing data which is spread over a space, over a horizontal space. As I have mentioned in the beginning of the slides, GIS contain data which is spread across a surface, any surface. So here spatial analysis means we are going to analyze those data. So we can use simple searching algorithms, we can use networks, we can build networks by connecting the data that we have, we can do buffering, corridor analysis, proximity analysis, Boolean analysis. So these are some ways where you can do analysis for the data. Right. So these are mostly mathematically related terms are here. So don't be afraid or don't think too much if you do not or if you haven't heard these terms. You can always go and search about them, but it is not very much related to your assignment and stuff. Right. So just know that there are these kind of ways to analyze data. And after analyzing the data and after creating results, you can create presentations or visualization. So just by analyzing the data and like after analyzing data, you will be getting a very large collection of data or information. Just by looking at that, you won't be able to come to a decision, or you won't be able to understand it at all. So it is recommended, or it is better that you can present the data, or you can visualize the data. So map making is the most popular way where GIS data can be visualized. We can create maps, or we can also create charts, tables, 3D views. You can generate animations. You can also do those stuff for the results that you get after analyzing GIS data. So GIS is used. Yeah, GIS can be used in multiple disciplines like this. So agriculture, journalism, history, lot of disciplines GIS can be used. So these are some examples. I think I have mentioned some examples on the previous day also. So farm management, pest and disease tracking, crop monitoring, yield prediction. So these kind of things happen in agriculture. In mostly in developed countries, GIS is being used for these kind of uh, analysis, right? Natural resource management, how we can manage our natural resources. So forestry, ecology, mining, petroleum, water resources. So these resources can be mapped and managed using GIS. So planning and economic development. So this right, even property tax, monitoring properties in the country and collecting tax or managing tax also can be used by with the help of GIS, right? Market analysis, transportation, all of them. So GIS is basically a framework for understanding and managing our Earth. So what we do is we in creation we do measuring, organizing, analyzing, modeling. So those kind of stuff we do in creating maps and other visualization. Geographic knowledge is holistic, it is comprehensive, systematic, analytic, and visual. So we can apply these GIS knowledge in planning, managing, and acting. So where geography can be applied? So what are the challenges in nowadays which require geographic approach can be seen here. So how GIS can be used as an infrastructure? Software licensing, instruction, data. So those things should be managed or managed in most areas because GIS is being used. So so data is the most important part in GIS if you are using GIS as an infrastructure. So data can be scattered in many departments. If you take one like one institute or one unit, data, there can be data in many departments, but these data will not be coordinated. But when we are using GIS, these data should be accessible anywhere. GIS portals and web services can be used for facilitate that thing, that the coordination of data, right? So libraries can be created, data centers can be created in order to store and relate GIS data, right? So this is one way where GIS can be used as an infrastructure, right? So there will be a network where there will be servers, GIS servers. So ArcGIS server, Portal Toolkit. So these can be GIS servers. So in GIS servers can use geodatabases, files, database management systems, and XMLs. So virtual globes, there is something called virtual globes where ArcGIS Explorer, Google Earth, Virtual Earth. So here you can explore or you can view the data which has been analyzed and which has been manipulated. Mobile GIS is also available. Desktop GIS, these are some software that you can use in your desktop, right? So like I said before, GIS can be used in many applications. So location allocation, I have sent you these slides, so you can just go through these are actually some practical usages of GIS. So vehicle routing, right? So here you can see optimal paths have been indicated for you to drive your vehicle, right? Right. So I'm just going to, so these are practical ways that you can use GIS. So I'm just going to skip these. You can just read about them and have an idea. So there is nothing to explain there. So we will be talking about the data structure. What are the kinds of data where data which will be used in GIS. So GIS use graphic data and alphanumeric data. All the data in the GIS can be divided into either graphic data or alphanumeric data. So alphanumeric data means non-spatial data. This data is not related to any spatial location. So as I have mentioned before, I told you all GIS data can be referred by the location, can be referred by its location. So when we talk about something on a map, we talk about, we can refer that point to a latitude and longitude value, right? Or any other location data that we know. But alphanumeric data means that is not data related to space or it is non-spatial data. So we call it attribute data. Attribute data is data about that spatial data, right? So so that is alphanumeric data. Graphic data, then again we divided into two parts. One is spatial data and the other one is non-spatial data. Graphic data again divides into non-spatial or attribute data. So this spatial data means any data which is spread among a space or a surface. So these data can be divided into vector and raster data, right? So vector data is the coordinate system that you have learned in your school days, like the Cartesian values or the Cartesian system, right? Or the latitude longitude coordinate system. So that is the vector data. Raster data means it is like some continuous data, image data, right? So aerial photography, remote sense or scanned images, right? Scanned images using remote sensing. Remote sensing means we are scanning or we are collecting the data by using sensors or using sensory equipment remotely, right? So satellite data is also some kind of remote sense data because the satellite is situated in a remote place and the images are being scanned very far from the satellite, right? And some other scanners can also record remotely scanned, remote sensed data or scanned images, right? So when it comes to maps, so maps are graphic representation of the perception of the world around us. So what is available around us, what is available in the world around us, we can convert them into a map, or we can draw them in a map, right? So they represent the cartographic interpretation and simplification of reality. So in the in reality, the world that we live in is round, right? It is a globe, but maps are two-dimensional. It is a square, right? A rectangle. We map everything in a rectangle, right? So there are certain conversion strategies when we convert what is in a globe into a rectangle. However, what we do is we do a cartographic representation, right? We interpret what is in a globe into a cartographic representation. So map provides two types of information: local information and spatial relationships, right? Locational information and spatial relationship. So locational information are information related to certain location. Maybe you can refer to that location using a latitude and longitude value or GPS value or a cartographic value, right? Using XY coordinates, you can refer to that location. And you can also have relationships between certain locations. So these relationships are known as spatial relationships, right? So maps contain three major features. So these are very important. These are the most important concepts when drawing a map. So these concepts are used in your QGIS application as well. So maps contain points, point features, line features and area features. So points, lines and area are used when we create a map. So we use only these three features. So if you just remember a map, if you remind of a map by yourselves, you can see on the map there are only points or lines or areas, nothing else, right? Just think about it. So points are point features. By using point features, we draw something or we locate something which can be indicated by one dot or one point. So things like wells, a well, control point, sample site, fire stations, a building, right, a school. We can indicate it using one dot or one point, right? So that is points. So points can be used to indicate certain single units, right? Then lines can be used to indicate things like roads, hydro lines, rivers, contour lines, right? What are contour lines? In contour lines, we measure, or we connect all the similar featured areas. So for example, if we are measuring the height of the land, right, height from the sea, height from the ocean level, so the similar, or the points where the height is the same, when we connect them all, we can create a contour where the height, contour which shows the height of the land, like that. So, and similarly we can use contours to draw temperature lines, right, like that. So however, line features can be used to construct a map. Area features are urban areas, water bodies, soil or rock units, forests, certain provincial areas, like that. So a vast area can be used to indicate using area features, right? So points, for lines and areas are used to show or create a map. So you can see here in this example also, there is a point, line and an area. So we'll talk about it. So when we talk about point features, points are spatially distributed entities, activities or events. So not only entities, not only buildings and trees or houses, like that, not only entities, we can also indicate activities. A place where an accident has happened, where a bomb blast took place. So those kind of activities or events can also be located on a map using points, right? So a tree, a traffic accident, a lamp post, things like that can be indicated using a point. So you can see here, this tree is a point, even though we do not have mapped it using a point. We haven't drawn a point here. However, this tree has its own latitude and longitude values, or one value in this spatial area, right? So the tree can be mapped or indicated as a point. So these are points. So wells, sample sites, huts, schools, clinics, those kind of things, buildings can be mapped using points. And then lines. Lines are spatially distributed entities, activities or events. So lines are a series of joined points. So we can say like that, line can be a collection of joined points. So roads, streams, railways, things like that can be drawn or can be indicated using line features. So lines can be divided into certain types. So there can be a simple line where just one line is there. Complex lines can also be there. Curves, right, not straight lines. Curves can be there, and networks. Networks can also be are also known as lines. So roads, rivers, power lines, false, or this kind of information can be indicated using lines. Then area features. So here these also spatially distributed entities, activities or events can be used to map using areas. So areas are also known as polygons, right? So you can see here this lake, Thompson's Lake, is used to be mapped as a area, the area feature. So a polygon is used to map this area, right? It is a series of geographic coordinates which is joined together. So these coordinates are joined together to form a boundary. So unlike in the the lines, so here in the line these coordinates are joined, but a boundary is not created here. But in areas, it forms a boundary. So lake, soil types, countries, provinces, that kind of features or that kind of information can be mapped using areas, right? So areas are also known as polygons. So points, lines and polygons are used in GIS to map certain features. So marsh, building, so some buildings, some a complex of buildings can be used to map using polygons, right? Forest, urban areas, lakes, farms, places like that. GIS can be, as I have mentioned previously, GIS have two forms of data. So one is vector data and one is raster, right? So all the spatial data that we use to map can be divided into two types, vector and raster. So you can see here the same unit or the same object is being modeled in two types, one using the raster model, one using the vector model. If you can see the difference, in the raster model what happens is the whole surface or the whole space is divided into small particles, right? The whole space is divided into small particles like this, and by filling each part or by filling each particle using certain maybe colors or intensities, we create our object, we make our object visual, right? But in vector data what we use is we do not divide the whole surface into parts. We use shapes or polygons, right? So you can see here the same object have been indicated, one by using the raster model and the other one using the vector model, right? So if further we talk about the raster format, data are divided into cells, pixels or elements. So you can see here the whole object or the whole image was divided into cells, or we can call it pixels or elements, right? These cells are organized in arrays. Each cell has a single value. So each cell has a value. So this value can be the intensity or the color of the cell, right? Color or any other value of the cell. So by differentiating the value of these cells, we create the objects, right? Row and column numbers are used to identify the location of the cell within the array. So all the cells have a row number and a column number. So digital image, when we take a digital image, if you zoom in a digital image up to a very large amount, then you will be able to see the pixels itself. Right? You will be able to see small dots or small squares in a digital image. So that is called, these squares are called pixels. So the digital image is an example of a raster format. So the whole image or the whole object is divided into cells or pixels. So a grid or a raster system store data as a string of characters in which each character represents a location. So all the squares here, all the pixels here in the raster model has a location, right? Each and every square has a location by itself. The basic data unit is a cell or pixel. So this pixel or cell has one value. An array of pixels form the entity. So the collection of pixels, when we take a collection of pixels, we can form the entities of points, lines and polygons, because these three entities are the ones which will be used to map things in GIS. So we have to use points, lines and polygons or areas. So if it is a raster data, if it is raster data, then the arrays of pixels are will be used to indicate points, lines and polygons, right? The shape and size of the array determines the basic resolution. The resolution of the image or the resolution of the map will be based on the shape and size of these elements. Polygons can be formed indicating areas of homogeneous characteristics. So homogeneous means likely, look-alike characteristics can be used to create polygons or indicating areas. So similar characteristics, pixels or elements with similar characteristics can be taken to form areas. So this is an image where raster data has been stored. So you can see this number 1 pixels, these yellow color pixels, they form the sand. So 1 is sand, 2 these green color pixels. So these pixels indicate grass. So number 3 is water. 4, these ash color pixels, they indicate house. And 5, there is a paving or pavement, right? So like that. So this is an image which is built using raster data. Then we will be talking about the vector format. So unlike in the raster format, the vector data is directly associated with points, lines or polygons or areas. So points are located by coordinates. Lines are described by series of connecting vectors. So lines have a size or a length of the line, Hello, can you hear me? Hello, can you hear me?
Yes.
Okay. Okay, I think there was some interruption. So we were talking about vector format. So yeah, so areas or polygons are described by a series of vectors enclosed in the area. So any number of factors or attributes can be associated with a point, line or polygon. So this you will be experiencing when you are doing your practicals. So attributes, there are attributes which can be related to a line, a point, line or polygon. So data, in this case, data is stored into files. So one file, it contains the location information, and the other file contains information about the attributes, right? So a third file contains information needed to link positional data with their attributes. So there are three files actually, but the third file you will not be able to see that file. However, that file has includes the connections or the links between the data and their attributes, right? So vector data or vector system store data as coordinates. So latitude and longitude values will be used to store vector data. So for example, each uniform area is surrounded by a set of straight line segment called vectors. So every point will be recorded by a pair of x and y coordinates or latitude and longitude values if they are available. So So straight line segments called vectors are displayed to indicate line-based data. So things like roads, rivers will be used to will be displayed using line-based data. Right. So vector data can display all most spatial features such as points, lines, and polygons. So yeah, here is the same image that we saw previously. We in the previous uh, time we saw it uh, as a raster image, but now here we are looking at it as a vector image or vector data. So you can see the same features are there: sand, grass, water, house, paving. Those features or those objects are there, but the look or the view is different. You can see here polygons have been used to uh, draw or locate that data, right? Polygons have been used in the previous time. uh, Certain pixels, the pixel values or the cell values were used to indicate the objects, but now here uh, polygons, total polygons have been created in order to indicate the objects. Okay. So maps will be, when we use map point, right, in the map feature point, if we want to indicate the point in a vector format, you can see we can indicate it using the x and y coordinate in space. If you want to indicate it using a raster format, we can indicate it using one cell located in an array. So one cell will indicate a point in raster format. Uh, one dot or one x and y coordinate will indicate a point in vector format. So similarly, if we talk about lines, the map feature line, so the vector format will indicate a line, right, with the direction itself. And if when we see it in the raster format, a collection of cells, right, collection of cells will indicate that line, right. So the when we come to raster format, it the clearness or the quality of the data will be increased with the resolution of the image. So if there are more and more cells, then we can smoothly represent this line in a raster format. But if there are less cells or less data, then using raster format is not good enough, right. So similarly, representing map feature, when we represent map feature in vector format, you can see lines, again lines can be used to indicate or represent map feature, but these lines will form in a way where a boundary is created. So there will be a direction to these lines, but these lines will form in a way where a boundary is created. So in raster format, on the other hand, you can again see that these pixel colors are used, or the pixel values are used to indicate the map feature, polygon in raster format, right. So when we compare vector and raster, so raster formats are efficient when comparing information among arrays with same cell size. If the information have same cell size, then it is okay when we compare in raster format. So raster files are generally very large because each cell occupies a separate line of data. Only one attribute can be assigned to each cell, and cell sizes are relatively small. So you can see here there are a lot of cells when it comes to raster format. There are a lot of cells. So all of these cells have their own value. So it is the raster format, an image in a raster format is relatively large because there are a lot of data stored in each and every cell, stored about each and every cell, and cell sizes are relatively small, and only one attribute can be assigned to each cell, right? Either the color or intensity or any other value. So when it comes to vector formats, it is efficient when comparing information whose geographical shapes and sizes are different. If the geographical shapes and sizes of objects are different, then vector formats are efficient when comparing and manipulating these objects. So vector files are much smaller because a small number of vectors can precisely describe large areas, and many attributes can be ascribed to these areas. So when we take one area like this in vector format, so a larger part of the area can be visualized with small number of information. So that's why these vector files are much smaller than raster. So most GIS software can display both raster and vector data. However, only a limited number of programs can analyze both types of data or make raster type analysis in vector format. So that is okay. So there are some other comparisons. Raster representations are relatively coarse and imprecise. Vector representations are very fine. or very precise. So you can see that here. So in raster representation, it is coarse. Coarse means it is not fine, it is not smooth enough. You can see there are certain, because the whole pixel will be colored in order to create the shape, but in certain places it will not be smooth enough. But in vector, the shapes are smooth, right? Okay. So yeah, when we talk about attribute data, attribute can be a numeric or alphanumeric data that is assigned to a point, line, or area. So attribute data is, some examples are like this: ID, right? Compartment number, vegetation type, name of something, type of road. So it is actually information about a point or a line or a polygon. When we draw a point, we can attach some other information for this point. So these information are kept separately but linked to that point, or same goes to the line, same goes to the polygon. So when we draw a line indicating a river, the attributes will be the river, the name of the river, the length of the river, uh, any other information about the river. So those information will be the attributes of that river, right? So you can see here spatial data. You can see the difference between spatial data and non-spatial data. So spatial data will be so in a map you will be able to see spatial data as well as non-spatial data. So in a database, you can see on the address column you can see spatial data. So this is the address. Address means some location on a spatial area, right? The address of your house means uh, it talks about a certain location on the space on our, right? But when you talk about the name of that person, it does not talk about a certain spatial location, right? We cannot relate your name to a latitude or longitude value. We cannot relate the name for x and y coordinates like that. We cannot do like that. So this is non-spatial. But on the map, you can draw or you can indicate the location where that address is, and you can say that this person lives here. You can add the name also, right? So spatial, when we talk about spatial data, we can indicate spatial data using x and y coordinate system, shapes, areas or sizes, perimeters, distance, neighborhood, those things. So attributes explain things about spatial data. uh, it can be non-spatial data as well. It can be words or numbers. It can be qualitative methods, quantitative methods. Anything can be used to used as attributes. So it is something which explains the spatial data. So yeah, these are some applications or some examples where GIS data sources are available. So we can use remote sensing using satellites and other sensory equipment, photogrammetry, digital data, right? So this is a very old digital data actually. Maps and plans, paper files, interviews, field surveys. So from all of these methods we can gather data for GIS, right? So existing data, digital data, map and plans, paper files, existing data sources for GIS. We can also acquire data through remote sensing, photogrammetry, field survey, like that. So some are low cost sources, some are high cost sources, right? So yeah, we can use databases to query graphic database, and yeah, we can like convert database to query graphic database, or we can convert graphics to graphic query database, like that. So yeah, we can get the digital format using scanning, digitizing, keyboard entry, right? So yeah, so these are some ways how we can produce digital data. These are some ways where we can acquire data. So this is how data entry, we can enter data. Data quality, we talked about data quality actually. So misconception of the data from GIS is of higher quality. So GIS use the latest technology. Normally GIS use latest technology. So quality of GIS information depends on quality of data, not on the quality of the technology actually. So if we input garbage, we output garbage. So garbage in, garbage out. If we input wrong data or low quality data, our results will also be wrong and low quality, right? So when the data quality is high, the cost is also high. However, at some point the data quality will be like, it will not increase much, but the cost will increase in a very higher rate. So precision means how closely several positions fall in relation to each other. Precise in spatial accuracy, when we say precise data, it indicates how several data are similar or are similar in characteristics. So accuracy means a measure of the closeness of one or more positions to a position that is known and defined in terms of an absolute reference system. Accuracy means correct data. So it is, we know that this data is correct. If another data set that we are analyzing falls into a similar position, then we can say that the accuracy of the new data set is also high, or like that, right? So when we are acquiring data, there can be errors happen. So device or instrument errors, due to the devices that we use, certain errors can happen. When we enter data entry errors can happen. In image interpretation errors, when we interpret an image, when we do some analysis for an image, then also certain errors can happen. That is when we acquire data, when we record data. So when we convert data from one type to another, again instrument inaccuracies can be there. The data errors can be happen due to the operator, because somebody will be there to convert data. So that person or that machine can that operator actually will create errors, right? Or due to the manuscript used, data errors can happen. So when we are storing data also, errors can happen. So sometimes digital representation might have limits. So for example, for an integer representation, if you are using int for some numeric to store some numerical value, if you are using int data format, then there will be a limit, right? So if you are using long data type, then you can store more data, more larger numbers in the long data type. So like that, if you have used integer or int data type, then you will have a limit where you can store data. Data means maybe decimal values. There will be a limit. So digital representation can have limits or disk storage limits. So when we are storing data in a hard drive or in a server, there can be storage limits. So normally, if we are using raster formats, then as I have mentioned previously, more space will be taken for raster formats, right? So errors can also happen using data processing at the data processing moment. So when you are rounding off, so if there are so many decimal values, if we normally round off, right? We round off the decimal values. So sometimes errors can happen due to rounding off. So when we are representing numbers in a digital format, a digital representation, right? Error propagation law. So information derived by mathematical operations no more accurate than the original information. So there can be differences when we are using mathematical operations to derive some data and when we practically measure the data, right? So in the practical world, there can be differences. So there also errors can happen. So this is so this is actually the concept of layers, using layers, right? So it is a very important concept in GIS as well as in the QGIS application also. When you can see, you will be seeing when you are doing your practicals, right? So if you want to see the whole world or the whole concept or the whole reality, we have to use all of these layers or all the parts, right? Countries, cities, zip codes, streets, school districts, homes. So all of these things come together and build a city or build the reality, right? So these are several examples where layers can be used, right? Okay, so these are some applications of geospatial analysis. You can, this is actually a small case study. You can read it by yourself. It is like some examples are given here. So you can, yeah, you can go through them and it is how this groundwater potential map was created, right? Yeah, these are the data that have been used, so you can go through them. I'm not going to explain this step by step, right? You can so these are the maps, certain maps that have been created. Okay. Yeah, so these are some conclusions about that case study, so you can go through them. I have sent this document to you guys. Okay, so we'll then come to our practical point, QGIS. Okay, so I hope okay, I'll just go through these screenshots here. So this is the environment of QGIS. I think you already have downloaded and installed it. I hope you have. I think I have mentioned in the last week. So this is the environment of your software. So this will be the canvas. So the canvas is the place where you will be building or you will be visualizing your maps. These are certain panels. So panels can be added and they can be removed according to your um, desire, right? So there is one panel called layers. So in this panel you will be seeing all the layers that you will be working on. And there are two toolbars. So on the top you will be able to see a certain toolbar where certain tools will be there, and on the side you might, or maybe uh, you will be need to insert this toolbar here. However, there can be several toolbars, right? And on the bottom there is a status bar where all the status regarding the map that you are creating, maybe the coordinate values, the coordinate referencing systems, or all of those information will be there in the status bar. And as in any application, there is a menu where you can add certain features, certain tools, and you can do certain things using these menus. Okay, so before moving on, some things that you should know is one is EPSG. There is something called EPSG, or European Petroleum Survey Group. It is a group or institute actually. What do? Is they publish a database of coordinate system information plus some very good related documents on map projections and data. Okay, so it is a group where they publish a database. In this database, there are coordinate system information. So coordinate system information regarding the whole world, and some documentations also. So I think I have mentioned previously, our world is a globe. So this what we are mapping on is a rectangle or a 2D surface. So when we are projecting the coordinates, global coordinates into this 2D surface, sometimes there are certain strategies used to convert these coordinates, right? So this EPSG is the institute actually where they publish these strategies and these kind of coordinates. So it is accepted globally, right? What they have published is accepted globally. So time by time they sometimes renew their publications, and map projections and stuff. So all of these, so what they are publishing are accepted globally. Okay, so the coordinate referencing system is another thing that you should know. It is a coordinate based local, regional or global system used to locate geographical entities. Again, the same story where our world is a global or a globe, and we have to project or map these coordinates into a 2D surface. Then this coordinate referencing system is being used. Um, it is this coordinate referencing system is based on regions or countries or local places, right? So if we are creating a map of Sri Lanka, we can use the coordinate referencing system which is more suitable for our country. So that is basically uh, related to India, right? India, it is like a time zone. So in a time, when we are using a time zone, we normally use, sometimes we use the time zone of India also, right? So like that, the coordinate referencing system, if we are using to create our maps, we have a, a similar or an ideal coordinate referencing system. So like that, if we are creating a map of Europe, there will be another coordinate referencing system which is ideal for creating maps of that region. So coordinate referencing system is based on local, regional or global systems, right? Okay, so finally we'll create a map. So if I start my application, QGIS, I think I have sent you making a map. Yeah, I have sent you this folder QGIS EX1 as I remember. I think I have sent you that folder. Yeah, making a map I have sent you. So it will be this folder QGIS EX1 making a map. Inside that folder you will be having a lot of resources, right? And there is a PDF document here, QGIS EX1, right? So using this PDF you will be able to step by step I have mentioned or have instructed and explained what you can do while creating a map, right? So so here when I open my QGIS application, you will be seeing this kind of view. So yeah, this is the canvas. So if I just close these things here. Okay, so this is the canvas. Here is the place where you will be loading the map. And so this is the browser. You can see you can load maps from various sources. And here there is a window called layers. So here you will be seeing the layers. Okay. Okay, so these are the one toolbar is here, and if you need, you will be Yeah, if you need, you can like add a toolbar separately, so that is according to your choice. So yeah, so when we are creating a map, so this is your handout. Your handout is there in that folder, QGIS EX1 making a map. Inside that folder, I have added a PDF document where it will act as a handout. So this tutorial actually shows how to create a map of Japan with standard map elements like grids, north arrow, scale bar, labels, like that. So map is not just when you're creating a map, you do not just include the terrain view, but you include some other information as well. For example, grids, arrows, scale bars, labels, those things should be there in a map. Otherwise, the person who is viewing the map will not be able to understand what is this map about. So the data set is already given to you. The natural Earth data set is given to you in this folder, right? So natural Earth quick start for GIS. So there are, this is you can see this is the QGIS project file, right? QGIS project file. There are three project files. You can use any of those three, but I will be using this natural Earth quick start for QGIS, this QGIS project file. Okay, so for this QGIS project file projects, these the other data inside these other folders, 10M cultural, 10M physical, like that. So there are certain folders here. The data inside these folders are needed for these project files. Okay, so do if you are copying these files, remember to copy these folders as well. Okay, so I'm using this natural earth quick start file. So here it comes with style global layers that can be loaded directly to QGIS. It is a map with certain styles and certain layers, so it can be loaded into this QGIS application. Okay, so this is how you are going to do it. You are going to open the file named of this natural earth quick start for QGIS. You just select the file and just open it, right? So I'm going to just use this project, open, and I'm going to go to that folder and select this file, natural earth quick start, and select open. So it will take a little bit of time to load all these layers. You can see in the layer window, you can see there are a lot of layers, right? Many layers, right? So in these layers, you can see, I think you will be able to see the type of these layers. For example, there is a tick or a checkbox, right? So this is the map. On my canvas, there is the map. You can use the scroll bar of your, not the scroll bar, you can use the wheel of your mouse. If you're using a mouse, you can use the wheel to zoom in and zoom out, right? So here I have zoom out, and I can zoom in. So I'm using the wheel of my mouse. Or you can if you are using a touch screen, you can span, you can use your two fingers to zoom in and zoom out, just as you zoom in and zoom out an image in your mobile phone, right? So that is if you are using a touchpad. So like that. And you can use your left mouse click, you can click, and you can move, you move. So we say that we are panning, right? Pan. So this is panning, right? So just click and move. So that is how you are going to move your map to the position that you like, right? So here are some here there are some ways that you can zoom in, zoom out, or zoom full. If we click this zoom full tool, the whole map will be zoomed into your canvas. Or pan map to selection. No, if you can click the zoom tool, and your cursor will be differentiated to that zoom tool. You can draw, right? You can click and drag to a position, and you can draw, and that area will be zoomed into your canvas, right? If I draw like this, that particular area will be zoomed in. So when you zoom out, you can just simply zoom out like this, right? So you can use these tools here and see what happens. And here in this layer window, you can see there are some check boxes. So you can check, all of these boxes are checked. So if you uncheck it, that layer will be hidden, or that layer will not be visualized here. So here if I uncheck this, pink color layer, you will see that pink color layer is hidden, right? And what you can see here is the other layers, right? The layer colors are given here, so you can get an idea about these layer colors, right? You can change these colors also, so I will let you know how to do that. But at the moment, you can see the colors of the layers. So those colors are available here, and you can see the type of the layer. So here you can see the first in my window, the first layer, NE10M populated places, that is the name of the layer. So if you move the cursor on top of that layer, you will be seeing some other information about that layer, and you will see that the type is point. The data type is point. So I have mentioned that in GIS there are points, lines, and polygons as how we can map anything. So here it is point. You can see a small dot here. So it means this layer is a point type layer. So if I zoom in, you can see there are small dots here. So I think that is this one. So if I untick this, yeah, those points will be hidden. So if I tick again, those points were available. So these are 1, 2, 3, 4. So similar points. Sorry. Similar points are shown here, right? So these are points, and this layer is a area layer or polygon layer. In this layer, polygons are there, right? It is indicated by this square, and these layers, you can see they are line based layers. Okay, so these are the things that you basically need to know while reading a map. You cannot actually create a map right now, but you can read the map. You can view how these layers are used to create this map. So you can move these layers on top of the other by just selecting and moving it into another position, right? So you can just select this and you can use these arrows, right? You can use these arrows to move upwards or downwards like that. Okay. Okay, so what we will do here now is we will have a break. So in the meantime, I will give you some time to just uh, so I need you to load the map, because I have sent you the resources. I need you to load the map to your QGIS application like this, and I need you to study. I need you to move these layers here and there, and I need you to study and be familiar with how this map is being built, right? So you can zoom in and zoom out and you can see what are the information. So related to our country, you can go and see what are the information which are being stored. And since I have given to you the handout here, you can actually try to build the map, a map of Japan or any other country that you like, that is okay. All right, so read this handout, and I mean, if you can understand, you can try and do what is there in this handout. However, I am going to do all the steps here, right? Don't worry, I'm going to show you and do all the steps here. So I'll give you a little bit of time, like 30 minutes time, right? So I'll come by 3:30, and let's start working on the map, how to build the map. But the thing is, in the meantime, I want you to be familiar with this application. That's why I am giving you 30 minutes time to be familiar with the application. Okay, you can use these menus and see what happens like that. Okay. Okay, so we'll come again. I'll come again at 3:30. So at the meantime, you can have your break and you can be familiar with the QGIS application as well. Okay. Okay, so what did you do? Were you able to look into the map? Yeah. So yeah, okay, so let's start. So this is the map of Japan. So in your handout, you can see here there are the layers of um, the layers available of the map, right? So, okay, so okay, so what we need to do is we need to create a map of Japan. So we first of all we have to zoom in towards Japan, and I have mentioned about the geographic coordinate system in your lecture note previously. So here there is a small description about the geographic coordinate system. So this here we have to select the appropriate projection. So it is best for us to select the appropriate geographic coordinate system where the units are degrees. Here the units are mentioned in degrees. So here the geographic coordinate system will be indicated to you at this point. So here you can see EPSG 4326. This is the default geographic coordinate system, right? WGS 84 or EPSG 4326. This is the default geographic coordinate system. So this is this is not appropriate if you do not know the geographic coordinate system. If they haven't mentioned for you to choose a particular geographic coordinate system, then it is okay to leave the default geographic coordinate system, which is EPSG 4326. But if they have mentioned some appropriate geographic coordinate system, you have to select it, you have to use it, right? So here we need to use a projected coordinate system. What happens is it minimizes distortions of the region that we have selected. So here we have selected Japan. Distortions will be minimized because we are going to select a geographic coordinate system which is related to Japan, right? So here we will use UTM zone 54N, right? So how we are going to use is we are going to click on this EPSG thing. When we click, a window will open, and here we can find, right? We can type. So here you can see WGS 84 EPSG 4326. This is the default one. So you can see there are many other geographic coordinate systems as well, right? So these coordinate systems are based on many countries. So here they have mentioned for you to select UTM 54, right? So you can type here UTM zone 54 zone. So here you can see there are UTM zone 54 54N, right? They have given 54N. So this is the one, UTM zone 54N. You can see here there is a WGS 84 one, right? So both of them are okay. When you select this, when you select the particular coordinate system, you can see here the region which is highlighted. The region which is highlighted, or the appropriate region where this coordinate system is applied is highlighted by red color, and by this purple color you can see this is the region that we have selected here, this region where our canvas is showing, right? So if these two regions tally with each other, then it is okay. So this one is also okay, this one is also okay. So I'm going to select any one of them, and I'm going to click apply. Okay, now it is applied, and I'm going to click OK. So this coordinate system, right? So you can see here EPSG 32454. It is the new one, right? This UTM zone 54 one, right? So for Japan plane rectangular coordinate system is a projected coordinate system that is designed for minimum distortions. It is divided into 18 zones, and if you are working for a smaller region in Japan, using this CRS will be better. So if we are like working for if we zoom in too much, if you want to work on certain things with very much zoomed situation in Japan, then using this coordinate system will be better, will be best. Okay, so yeah, this is how you are going to select this UTM 54 one, right? Okay, and now we are going to create the map. So how we are going to create this is I'm going to zoom out for the entire map of Japan like this, and zoom out a little bit. Okay, so now yeah, I'm going to zoom out, or I can also do something like this. I'm going to zoom to the particular point, particular region that I want, right? And then I'm going to select this project menu, and I'm going to go to new print layout. I'm going to select this new print layout. So this, you can give a title, so it will be the name of the map that you are going to create. If you can give any name that you like. So I'm going to give map of Japan. I'm going to select OK, and then a new window will be open. So here there is a new canvas, right? A new canvas will be here. So we are going to create our map on this canvas. So the previous canvas is the existing map that is given to us. So from the existing world map, we are going to take a portion, or we are going to create the map of Japan only. So that part, the part that we have zoomed in here, we want it to be placed on this canvas. So for that, what we are going to do is, we are going to click on this add map, right? We are going to click on this add map. So add map can be clicked here, or in add item also we can select this add map menu, right? So when we clicked on add map, you can see the cursor, the shape of the cursor is changed. It is a crosshair now. So what we are going to do is, we are going to draw a rectangle or draw a square where the map in our canvas should be placed on top of this canvas here, right? So I'm not going to start from the end of this canvas. I'm going to just leave a little bit of space here, right? And then draw a square like this. Okay, I'm going to draw a square like this. And then I'm going to release my key, and then you can see the map on the canvas will be shown here, right? So this is the map I'm going to create, and then I'm going to add some other details to on top of this map, right? So this is the basic map that I'm going to create. So if I go to the canvas again, if I zoom in a bit, so now I have zoomed in, and then if I come to my map of Japan here again, if I refresh it, yeah, I have refreshed it, but this map does not change, right? This is the refresh button. So this map doesn't change, but here I can zoom in, I can zoom in the map here, not, I can zoom in the canvas, but this map doesn't change even though the map in that canvas, this canvas has changed, right? So but if okay, so this is the map that I am going to create, and then what, let's see, what do we need to do? So this is how we are going to add maps. So we can we can change the map characteristic, we can adjust the zoom level of the map, uh, okay, so here, so this is the map, this map 1 is the map that we have drawn here. So here under the layout tab there are certain characteristics, so we can change the grid spacing and stuff, but before that I'll let you see the item properties. So the item properties is related to any item that we have selected here. So here we only have one item, that is map 1. So properties of this item can be differed. So this is the scale of the map, right? This is the map rotation. So if you like rotate the map, this will be rotated, right? So it is very okay, it is still processing here. Okay, you can see here that it has been rotated, right, after some point. So yeah, I'm going to make it 0 again. Okay, so it is it has come to its yeah, type again. So follow map, if I follow map theme, if I click on follow map theme, then if I like let's say I'm going to remove this layer, and then if I refresh here, yeah, if I refresh here, you can see the changes that I do to this theme, the changes that I did to this map have been applied here also. So that is if I follow map theme, right? So if I lock layers, then what happens is, so I lock layers and lock styles for layers. Then if I like enable this again, and if I refresh this, then this map will not be changed. So you can see I have changed the colors again, the styles again, but here if I refresh this map, that changes will not be applied to this map because I have locked the layers of this map. So if you want to like secure your map here, you can always lock the layers, then the changes will not be applied, the changes which will happen in here will not be applied to the changes here, right? So I'm going to just keep it as it is, and so you can check on these other styles and stuff. So I'm going to talk about grids here. So here grid, if you want to add a grid means you know what a grid is. So the horizontal and vertical lines which are appeared on top of the map, we normally call it as a grid. So if I want to add a grid, I'll just select this grids drop down button, and then I will add. So here we can add a new grid. So just by simply clicking on it, a new grid will be added. So we can select this new grid which is named as grid 1 defaultly. So we can select modify grid, and you can see you can yeah, modify this grid. You can select the grid type, right? So use map CRS. If I use centimeters and let's say the intervals, I'll use map lyrics. Oh. Okay, so the intervals are 10 by 10 centimeters here on this map, and y side also I'm going to keep, sorry, keep like that. Okay, so here also I'll keep as 5. Okay, so these are the grids. You can select a line style, or you can select a line color for the grid. So that is how you prefer. So the blending style, how these grids are being blended to the map. So those kind of things you can select. We can add a frame also. Okay, so in grids and frames we can add a frame also. So let's say I'm going to add a zebra frame like this. We can add any kind of frames you can add. So this is for the map itself. So I'm going to add this one, and you can change the frame size, you can change the frame margins, right, like this. So I'm going to just keep it as it is, and the frame line thickness, fill colors, all those stuff you can change, right? Okay, and then it comes here you can draw coordinates. So when you tick this draw coordinate checkbox, you can see the coordinate values have been appeared here. But the thing is, you can see the white color square, right? So that is the canvas, and when you save this map as an image, only the things inside this white color square, the square which was there at the beginning, right? The white color square or the canvas itself. So the things which are inside the canvas will only be saved. So these, you can see these number of zeros which have come out of the canvas, they will not be seen when you save your image, save this map as an image, when you save this map as an image. So I'm going to, like, I don't want these decimal numbers. So what I'm going to do is, okay, I'm going to leave this decimal, but yeah, I'm going to put it into the inside frame, right? So left, and right also I'm going to put it inside, but top and bottom it is okay to be outside. I'm going to, yeah, the coordinate precision, I'm going to remove the decimal numbers. So let's see if it is okay if I move this into the outside frame. Yeah, it will be fine, right? Because here also I'm going to move it to the outside frame. So without the decimal numbers, the numeric, the whole number will be appeared here. So that is fine for the coordinates, right? Right, so these are some item properties which are related with grids. So you can add those properties like this, and you can go back by selecting this arrow, right? You can go back to the place where you have added a grid, right? Oops. Okay, so now what I'm going to do next is I'm going to select another map to add on top of the previous map. So I have added one map here, you can see. So I'm going to select another map. Another map means a small location, a small portion of the Tokyo map. So what I'm going to do is, yeah, I'm going, so in the similar way that we have added the whole map, I'm going to add this particular map, this small map, where this, what do you say, Kyoto and Nagoya, right? Kyoto and Nagoya. where these particular villages are being seen, right? So I'm going to zoom in like this, and I'm going to add this map on top of the map that I have already created. So what I'm going to do is I'm going to zoom in to the position to the map that I want to add, like I did previously, and then I'm going to select this map, and again I'm going to add a map. So I'm going to click on add map, and then I'm going to add that map here. So I'm going to draw a square like this, and then I'm going to release the click. So here you can see this is the place where I have zoomed in the previous map, right? So you can see the new map here, and you can see the new map has been appeared as map 2, right? So you can tick and untick to make the visuality enabled or disabled. So you can click on this new map, and again you can add item properties for the new map, right? So map 2, when you click on this map 2, so I'm going to again follow map theme, and I'm going to untick this. What is this one? I'm going to because I need this map also be a part of this one, so I'll refresh. Okay, so this is the new map that I have added. So you cannot clearly visualize the new map and the old map, so I'm going to make it correct by adding some frames and stuff. So here again I'm going to lock the layers and styles. So remember, I have selected this map 2. Okay, the map 2 is being selected. Then I'm going to add this. I'm going to add a frame. So here you can see I'm not going to add grids for this map, right? So grids I'm not going to add, but I'm going to add a frame. So I'm going to click on this frame, and the color is okay, and I'm going to increase the thickness a bit like this, so I can distinguish between the newly entered map and the old one. So the join style, yeah, I'll put it as round, and okay, so this is the new map, right? But the thing is, I also want to mention in from where this new map I have taken. Like in the old map, I want to highlight, yeah, from this position. This is the place that is like zoomed in here. For that way, I can add an overview. So I'm going to add an overview for the map 1, for the previous map that I have selected, right? So I'm going to select map 1 here, and under the item properties of map 1, I can see overviews, right? There is an option called overviews here, right? So add a new overview by clicking on this button, right? So overview 1 will be added. So for overview 1, I have to select which map should be mentioned as an overview here. So the only other map which is available is map 2. So I'm going to create, yeah, I have selected map 2, and you can see something is highlighted here, right, in red color. You can see that something is highlighted here in red color. So what has happened there is this map from where that map is taken is being highlighted here, right? So since it is highlighted in red color, it is not not clearly seen because the background is also in it takes a red color. So what I'm going to do is I'm going to select the color from here. Oh, sorry. Yeah, I'm going to select color from here. Let's see. Yeah, and I'm going to select transparency. I'm going to add some transparency by selecting yeah, this kind of position is okay. So you can see this is the place, this is the part of the map that I have expanded in here, right? So this is that. So the blending mode, you can select any mode you like according to your desire. Yeah, position below map labels. So below the map labels, so below this label Osaka, you can see the overview, right? Okay, so like that I can add the overview. So the overview means from where I have selected an expanded map. So remember, when you are adding an overview, you have to add the overview to the map, to the like the mother map or the map that you have the main map, right? When you're adding an overview, you have to add the map to the main map, right? And then you have to select which map should be added as an overview. So here uh, under the overview options, you can see map frame. So the other map that which map you want to add as an overview is available here, right? Okay, so yeah, so that is how to add another map and make an overview. Yeah, so we have already added a grid to the map also. If you like, you can change the CRS of the grids also. That is up to you. And we can change the grid appearance, interval values, grid frames. So so for map 1, yeah, under grids you can go to modify grid and you can can use map units. Sorry. What happened there? Okay, give me a second. This is taking some processing time here. Okay, so you can yeah, this is taking too much time. It is not responding as well. So you can try this changing the grid appearance, like to this kind of grids, right? You can try this on your own. I'm just what happened? Okay, I'll just let you know how this can be. Okay, so here again you can, so these are the other elements that you can add to a map. So you can add a north arrow to the map. So keep in mind that an arrow is a very important part in a map, because we need to know which way is the north, right? So just by looking at the map, sometimes we cannot identify the direction. So which way is the north, we need to know. So we need to add a north arrow. So we can add an image of an arrow. So here what you can do is, you can there's an option here as add image. So yeah, my application is not responding somehow. I don't know why. So there is an option here. So this is the option to add an image. Just let me. I'll just quickly open and just show you how to add these other stuff. Okay, so you can add an arrow. You can add a north arrow. So there will be a couple of several images. So you can select any arrow that you like, and yeah, a scale bar. So a scale bar is also a very important part in a map. So what is the scale from the original view of the earth and to the map that you have created. Okay, so I'm going to quickly add open this project file, and I'm just going to I'm going to quickly add this thing to the print layout. So I'll add a map like this. Okay, so other properties you can add. Okay, so the frames and grids and stuff you can add by yourself, and you can add another map and make an overview, right? So I'm going to add an arrow. I'm going to do from that point onwards. So when you click on add picture, again a crosshair is coming, and I'm going to add the arrow at this position like this. So I'm going to draw a square where the arrow will be available, and you can see the item properties. So I can click on arrows and can adjust these things little bit. So under item properties, since I want arrows, I will click on this arrows folder, and you can see images, right? SVG images are here. So I'm going to just select one arrow like this. Yeah, I'll select this one. So you can see this is one type of arrow. Okay, so it will appear like that. So I'm going to adjust a little bit like this. Okay, so now it is okay. So this is one, this is the north arrow that I'm going to add to my map. Then yeah, the other one is the scale bar. So again I can add a scale bar. So here you can see this is the option to add a scale bar. So when you click on that, again the cursor becomes a crosshair. So I am going to add the scale bar like this. So normally scale bars are rectangular like this. So you can see a scale bar is being added. So I can adjust this. So when you click on this scale bar, you can see the under these items tab, the scale bar will appear. So this picture is the arrow. The scale bar, when you click on the scale bar, you can see the item properties of the scale bar. So you can, the scale bar units, you can mention the scale bar units, the label unit, right? So if you want to customize the number format, you can, yeah, customize it. You can write decimal places or significant figures or things like that. Right, the sample will be shown here. Okay, and the segments that you want to show here, right? So things like that you can change, right? So under this display option, this primary fill and secondary fill, you can select the colors if you like. So you can select it like this. So I'm just going to keep it like this, right? The line style, positions, if you need to add a frame to the scale bar, right, like this. If you need to add the scale to the to the scale bar, you can add it. If you want to add a background, you can add to the scale bar. So I'm just going to leave like this. Okay, so these are the things, these are the properties which you can change using the properties of the scale bar. So like that you can add the scale bar, and you can add a label. So all maps have labels, so you can add a label. So a label will come like this. So this is the label. Click on the label and then you can add it like this. So when you just create a, like when you draw a rectangle, you can see under So this is the label, right? So here you can see the text. Here you can write any text that you like related to this map. So I'm just going to write map of Japan. So I can create I can customize the font. Okay, so I'm going to leave it like this. I can add the font, I can make it bold, I can underline or anything, right? So just I'm going to leave it like this, right? Yes, I'm going to center a line, and I'm going to make it keep it like this. Okay, so okay, so there are some other items here you can check and add. For example, you can add the legend. So legends means so when you add a legend, actually what will come here is the layers, right? The layers which are available in your canvas here, these layers, right? These are the layers which will come when you are adding the legend. So if you want to like keep all the layers, then you can leave it like this. Otherwise you can remove some layers. Okay, so you can click on this only show items inside the linked map. So all the items inside this map will be shown here. Sorry, not this one. Okay, so oops. Yeah, you can change the alignments like this. Yeah, you can untick this auto update feature, and then you can remove the legends that you do not need to have in here. So for example, I cannot see these green color, yellow color things much. So for Japan, so for things related to Japan, these only a very few legends is okay. So yeah, I'm just going to like remove certain legends that I do not need, right? So here okay, so this one also not needed. Yeah, I'll probably leave these other legends here. So this one also it is better to remove. Okay, so it is up to you what you can keep or what you will remove. So since the whole world map is not indicated here, only the things related to this map can be mentioned here, right? Okay, So like that I can add a legend also. Mm, so you can add a north arrow using this button also. You can add an image like this, or you can add a north arrow like this also, right? Just draw it and a north arrow will be appeared. So I'm going to remove it. So I have added it using this button here, right? You can add shapes. Actually it is not very much required at this moment, but in some maps you will be needed to add shapes. So you can add a shape like this, right? So when you select this shape, yeah, this is the shape, a triangle, and you can add different styles. Yeah, you can add styles to these shapes. You can change the position, the rotation and stuff of these shapes. So like that you can do any customization that you like. Okay, so maybe you need to, like, if you are required to uh, show something on the map, uh, to point something on the map, then you can add a shape and indicate that this is the particular thing. So here if I want to add, maybe, I don't know, indicate some monument or some building on this map, then I can add a shape like this, and I can add a label to indicate what is mentioned by this shape, right? So like this I can maybe add a label to indicate what is mentioned by this shape, right? Okay, so markers are also some ways to add certain uh, certain marks or certain points on a map. So you can add a marker. You just have to click on one point, right? Then that marker will be added. So it is here also, it a marker is also can also be used to uh, the same reason that I have mentioned previously, maybe to uh, show a building, maybe to show a particular incident which has happened on a map. So like that, so you can, like that, you can add a marker. So it is something that you can use to highlight a particular point on the map, right? And you can add arrows, right? When you're adding arrows, what you have to do is you click on this arrow, uh, this icon, and you can do something like this. You click at one point, just click, okay, not drag, just click. When you click on a point, you can see when you move your mouse freely, the arrow will be drawn according to the cursor position. So when you come to the point that you want to draw the arrow, or you want to draw the arrow head, you have to right click it, right? You have to right click at the ending position. Where is it? Okay, if I start again. Okay, so this is the polyline. I'm going to remove this item. Yeah, so if I'm going to add this again, click. Okay, so just click, and then at the end you can right click. Then afterwards you can change the position of the arrow. That is okay, right? So here I have drawn an arrow. So when you click on this arrow, so the arrow will become a polyline, right? The arrow will be shown here as a polyline. So you can click on this polyline and you can change its item properties also, right? So here you can change the properties. I'm going to just leave it black. So start marker will have nothing, end marker will have an arrow. So the arrow stroke color, arrow fill color, arrow stroke width, you can change. Arrow head width you can change, right? So the other variables also you can change. So you can do it on your own. I'm just showing that you can do like this. Okay, so yeah, I have drawn this arrow and I'm going to label this part also, like I don't know, the bang or something like that. Okay, so it happened here, the earthquake, or yeah, right. Okay. So like that you can customize your map, right? So there are some other options that you can add. You can add a node item, you can add some HTML features, you can add an attribute table, like that. So there are some other features that you can add, right? So you can uh, go and I mean, at home you can do by yourself. You can please play with these yeah, play with these tools and see what things you can do to your map, what changes you can do to your map, what customizations you can do, right? So, and remember, in your assignments you have to create maps like this. So all the layers and stuff will be given to you, and what you are required to show will be given to you. So what you have to do is you have to create a map. So certain analysis parts are also required from you. So you have to sometimes analyze things and you have to explain, right? When you are explaining, you have to show it in a map, right? Because since you are doing GIS here, you cannot just explain it in a paragraph and just leave it as it is. No, you have to show what you have explained, or you have to confirm, or you have to prove your explanation using a map. So for that you have to create maps, and when you are creating maps, remember you have to include all of these, at least most of these features. You have to include the grid, you have to include the north arrow, right? And you have to include the map label, what kind, I mean, what is the map that you have showing, the name of the map, The legend you can include, or sometimes if there are very long labels or very long legends, or if the layers are named in a very long names, then you can omit the legends. It is not a must, but the scales, the map frames, the coordinates, those stuff you have to include, right? So in order to be a complete map, those essential parts you have to include, right? The north arrow, the name of the map, the scale, the coordinates, grids or coordinates, those things you have to include, right? The legends is okay if you do not include, that is fine, but the other stuff you have. Okay, so for every assignment that you, for all the questions that you are answering in your assignment, if a map is required, then you have to build the map like this, and you have to attach it as an image. So how to export this map is, you can click on layout and you can select export as image, or you can export as SVG, or you can export as PDF. So exporting as image, if you click on that, you can I'm going to export this map into the folder, this making a map folder. So the file name will be Japan, which is default, which is the name that I have given when opening this canvas. So I'm going to save it like it is, and the resolutions and stuff are given here. I'm not going to change anything, I'm just going to save it like that. Okay, so it will take a bit of time since I have added a lot of things. So after exporting, a success message will appear. So if I go and see here, yeah, this is Japan. Japan means the map that I have created here. So if I open it, you can see, yeah, this is the map that I have created. So remember, this is the canvas, the borders of the canvas. So anything which is outside of the canvas will not be included in your image, right? Anything outside the canvas will not be included in your image. So keep that in mind. Okay, so that is how you are going to create a map. So please practice. So I have taken a little bit of time for explaining this step by step to you, because you are still not familiar with the application, and the application is very new. I don't know whether you have used this or not, but in this module, this is the first day of using this application. So I have taken somewhat time to explain to you, but you are the ones who have to practice this, right? You are the ones who have to practice these, changing these properties and changing item properties and stuff. You are the ones who have to do it, right? So there are some other tools here as well. Please go and check what you can do with these tools, right? There are some other menus. Right, rise, lower, bring to front, send to back. So these are some things you might be able to understand. So if you have anything that you do not understand, you can always check things online. There are tutorials regarding to this application, so many tutorials, so you can check and learn, right? And also I have sent you another activity 1, making a map, right? I have sent you this folder as well. Yeah, activity 1, making a map. I have sent you this folder as well. And the other exercise 2 will cover on the other day. So working with attributes. I have sent you, if you need, I mean, if you need to do it at home by yourself, you can do it. This is this second exercise, which covers about attributes. And the second activity is also there, working with attributes. You can do both of these two activities if you like, right? However, I'm going to cover this activity on the next day. Okay, so the handout will be there inside this folder, so you can go through it and do it by yourself if you like. However, this activity 1, making a map, activity 1, okay, so inside that folder there will be another folder called Sri Lanka SHP. SHP means shape files. So all the shape files, a set of shape files will be there inside this folder. So what you are going to do is, so here in this activity here, so I'm going to close this. In this activity, what I did was I just loaded some QGIS project file, right? So inside this QGIS project file, all of these shape files were there. But here in this folder that I have sent to you, there are no project files like that. What you have to do is you have to add this shape files. Shape files are the files with the extension .shp, or you can look into the file type and see the SHP file, right? So you have to load the SHP files to the canvas here. So it is something like this. So I'm going to let's see, I'm going to select all of these layers and I'm going to remove them. Okay, so when I remove these layers, you can see there is nothing available in the canvas. So what I'm doing here is I'm going to open the other folder that I have given to you. So no, I'm not going to save the current project. So here activity 1, inside this one, this, okay, so project files are not there. Okay, it doesn't show the shape files. That is fine. Then if you cannot load the shape files from there, you can always go to the browser here. You can see the browser. So inside the browser you can go to your computer. Okay, so inside this Sri Lanka SHP, you can see the shape file. So only the shape files will be visible here. So you can just simply click and drag and drop into this layers section, right? So either one by one, or maybe you can select all of these things by selecting shift, click on the shift button and click on the shape files, and then you can drag and drop into here. Okay, so just select these shape files and drag and drop into this layers section. So here also you can see this is related to the Sri Lanka, to our country. contours, districts, divisional secretaries, forests, lagoons, so things like that, tanks, cities, boundaries are being shown here. So you can always move these legends, move these layers on top of the other layers, so you can visually see. So for example, if you have points, it is better to move the points onto the top. Otherwise, if the points are at the bottom, it will be covered from this area layers, right? And after points, it is better to move these lines on top, right? After points, lines will be best, right? So so if I move this, so this is divisional secretary stuff. Lagoons are also small locations, so these are lagoons, so better move these lagoons on top. Let's see how, if I move cities, okay, cities are also small parts, so like that you have to move these layers here and there and see and get the best view of the country or best view of the map, right? So the boundaries, like that, it is better if you can move these things. So for example, if I move the district layer on top of the other ones, I will not be able to see the forests and tanks, which are small, very small areas or polygons. So it is better if I keep the district at the bottom and view these other layers, right? So whenever you get a set of shape files or whenever you get a set of layers, you must adjust, you must move these layers on top of the others and see your optimal map, right? See the adjust it to see the map, most of the map, right? You must adjust the layers to see the most of the map. So this is better if you can put the points on top, then the lines, and afterwards the polygons. And when you are moving the polygons also, see there are small polygons, right? Small areas are covered in some polygons, so better move that small area covered polygons on top, onto the top. Okay, so like that you have to adjust to make the best view of the map. Okay, so what you have to do in this map, I have given it in the PDF file that is inside that folder, right? So it is a very small activity. Small activity means that is the same activity, the same things that we did with the map of Japan, you must do here. Only the difference is that this map is pretty much related to you guys because it is a map of Sri Lanka. And yeah, here you can see in the second part, you have to reorder the layers appropriately so that you are able to view most of the items of the map. Okay, reorder the layers, and you have to build an overview of Puttalam Lagoon. I think everybody of you know where the Puttalam Lagoon is, right? Puttalam Lagoon. If you do not know, just go search in somewhere and see, right? So things are not marked here. Unlike in the previous map, there are no labels in here in this map, right? So find where the Puttalam Lagoon is and mark it in this map, right? So and you have to build an overview similar to the overview that we built in our previous map, in the map of Japan, if you can remember. You have to build an overview. You have to enlarge the Puttalam Lagoon, and you have to build an overview of that, right? And then you have to include all the other map elements like the arrows, grids, scales, labels, everything you have to add, right? And then finally you have to export this map as an image, right? So everybody must do it, and I need you to come up with the images on the next day. So I will be asking for the images. So you can like share your screen and show the images that image of the map that you have created, right? So and you have to explain what, like how you did it, right? That describe the map. So you have to describe what are the values of the grids that you have, the interval values of the grids you have included, what will be the scale of your map, where the north arrow is, what are the labels you have added, things like that you have to describe. Okay, so I will be asking about this map on the next day before starting the lecture, right? So everybody should do this activity and export the map as an image and come with that image, right? Okay, so any questions regarding what we did today?
Excuse me, Miss.
Yep.
Uh, can you send us the what we needed to download the correct link and version in QGIS?
I'll just show you. Yeah, I only downloaded it today, so just yeah, you just type QGIS download on the Google, and on top of everything there will be a link called download QGIS. You can click on it, and you don't download the first this. I think this is a very large file size. Go to the bottom. So here, this one. So since my machine is a 64-bit, so I downloaded this one. I think it is like 3 to 400 megabyte file, right? So this is the one that I have downloaded. This is the one that I have installed and showed to you. Okay, so the file here was very large, above 1 GB, I think. So that is not required. You can download this one or this one according to your version.
Okay, thank you, Miss.
Okay. Okay, any other questions? I don't know whether you can get a copy from your institute. If you like, you can ask them and you can get a copy of of this QGIS from your institute. I don't know whether they will provide or not, just in case. Any other questions?
Can you please grant access
Sorry,
those files?
I can't hear you properly. Can you repeat?
Hello?
Yeah.
Ma'am, can you please grant access for download those stuff that Sanidhu has
Okay.
mailed? It says
Okay, I'll look into it. I actually gave the permission. I don't know. I'll look into it and sort it out with Sanidu.
Okay, thank you, madam.
So if you do not have access, maybe I think you can ask for access, right? Then an email comes to me. So several people have asked for access and I gave access to them. I don't know whether it worked. Yeah, Vishwi has asked, requested for access again. I'll grant it. Gishanti has requested access for some files. I have granted access. Please check with them. Or otherwise, I'll again share the files. Let's see. Yeah, I have given access as editor actually. Yeah. Okay, any other things you need to know? Vishwi, can you check whether you can, is Vishwi here?
Yes, ma'am. Now I can download.
Now you can, right? So if
Thank
your
you.
okay, if your colleagues have any issues with access, can you share your files with them?
Sure.
Okay. If you so anyhow, if you have issues with access, you can just ask for granting access. I will grant access from here. It is not a big deal. Or otherwise, you can ask Vishwi because Vishwi has got all the files with her, I think, by now. Okay. Okay then. So if you do not have any questions, let's stop for today and we'll meet on the next week.
Thank you very much.
Yeah, have a nice week.
Thank you, ma'am.